Two tanker operations that have the greatest impact on the safety of personnel and of the environment are cargo tank cleaning for man entry and the disposal of slops. On completing this chapter, you will have an understanding of why following a good plan of tank cleaning operations helps in the safety of personnel, why the location of the ship, the condition of oil in the bottom, and oxygen in the atmosphere of tanks should be checked in preparing for tank cleaning, apart from ensuring that the vessel is not in one of the designated MARPOL special areas, when the overboard discharge line blank should be removed, how to take in water safely for tank cleaning, what is open cycle water washing, and the advantages of closed cycle water washing, why purging with inert gas is necessary, and when a tank is gas-free enough for crew to enter. All tank cleaning, including crude oil washing and discharge or decanting of water from slop tanks, is to be recorded in the Oil Record Book, Part 2. When it is decided to carry out tank cleaning, water washing, and gas freeing for entry on a crude oil tanker, the procedure will be as follows. Preparations before tank cleaning. Taking in water for washing. Washing the tanks. Open cycle. Washing tanks. Closed cycle. Lines flushing and stripping. Purging and gas-freeing tanks for man entry. Click on the Why is a good, detailed plan for tank cleaning crucial from the point of view of safety of personnel? The preparations before a tank cleaning operation is undertaken must include a good detailed plan for the tank washing operations, including the time for each of the stages, the tanks to be washed, the lines to be flushed, and the location at sea of the tank cleaning and the decanting of the tank washings into the sea, all according to MARPOL. Work and rest hours rotation of key personnel, including the pumpman and deck crew, is critical because of the most hazardous nature of these operations. The plan should ensure that they are rested and available at critical times, such as when lines are to be flushed or equipment to be shifted from one tank to another. Why is the location, the free oil in pipelines and tank bottoms, and the atmosphere in the tank important while preparing for tank washing? Location. If time allows, it is always beneficial to carry out tank cleaning when the seawater has reached its highest temperature en route. Warm water is more effective in washing oil tanks than cold water. Tank bottoms and pipelines stripping. If discharge has been carried out in a cold climate port, it is also good practice to drain all cargo tank bottoms after entering warmer seawater. Not so important on double hull tankers. Tank atmosphere preparation. Start the operation by checking the atmosphere in the slop tanks and the cargo tank to be washed. Prepare the inert gas system. The requirements for oxygen content in inert gas supply and in the tank atmosphere are the same as for crude oil washing, respectively 5% and 8%. Why should the sea chest valve never be opened until the washing pump has been started and there is a part vacuum on the inboard side of the sea chest valve? Top up the inert gas pressure of the tanks if they are in a low pressure. Drain the crude oil washing line into the primary slop. Line up the pump which is to be used for cleaning and delivery into the crude oil washing line to take suction from the sea chest. The sea suction valve must never be opened until the pump is started and there is a negative pressure on the inboard side of the valve. This is to prevent any oil traces in the cargo line leaking overboard through the sea chest. Start the pump. Open machine valves to clean the crude oil washing line into the cargo tanks to be cleaned. Fill the primary slop tank, on the right in the diagram. to the level at which it covers the inlet pipe. Tank washing water should never be allowed to free fall into a slop tank because of the risk of sparks caused by static electricity. Most slop tanks are fitted with an inlet diffuser in order to prevent static electric sparks. Line up the stripping eductor for discharge into the primary slop tank. What is the special feature of open cycle tank cleaning with water? For open cycle cleaning, set the pump to take suction from the sea, and the eductor to discharge into the primary slop tank, from which water is decanted in 2 stages through the secondary slop tank into the open sea. Start the ODME system. It is often possible for the washing water decanted from the secondary slop tank to be clean enough to be allowed by the ODME to drain directly into the sea. Because of the large volume of water used, this is not suited for hot water washing. What is the aim of washing the secondary slop tanks first? Drain the bottom of the secondary slop into the primary slop. Then first wash this secondary slop tank on the left in the diagram using a full wash cycle program of the machines. The aim is to keep this secondary tank as free of oil as possible, as it is to be used for the second stage of decanting out clean water into the sea or for washing. After stripping this tank dry, fill it with water to a level above the inlets of the overflow line from the primary slop. Start bottom stripping of all cargo tank bottoms. Adjust the crude oil washing machines to the starting program in the tank to be cleaned next. When the above items have been carried out, start the washing machines in the cargo tank and clean the tank according to the operations and procedure manual until the tank is clean. When the slop tanks have reached the level where overflow by gravity from the primary to the secondary tank can commence, open the gravity overboard line in the secondary slop. The primary slop tank will now act as a separator. The oily water from the cargo tank will settle. The bulk of the oil will accumulate on the surface of the tank. As the overflow from the primary to the secondary slop is driven by gravity, the relatively clean water in the bottom of the primary tank is pushed into the overflow line at the bottom level. The overflow water from the primary slop enters the secondary slop at a high level, and any traces of oil will also settle on top of the surface in the secondary slop. The overboard flow from the secondary slop to sea is activated by the same gravity effect as above. What is the special feature of closed-cycle water washing of cargo tanks? For the closed cycle, set the pumps to take suction from the secondary slop tank or even the primary slop tank itself if heating fuel is to be conserved, and for the educator to discharge into the primary slop tank. A closed cycle is always used when hot water washing is required, as with certain high wax content cargoes. The water in a single stop tank is heated using the steam heating coils in it, and then it is passed through the steam heater in the pump room until the desired temperature is achieved. Water is used from the slop tank and returned to the slop tank. Thus, using a closed cycle limits the amount of water used for tank cleaning and avoids waste of heating fuel in the case of hot water washing required for some waxy crudes. Why is it important to flush the cargo lines with water and strip them dry before gas freeing is done for maintenance? When the tank cleaning is completed and the tank is thoroughly drained, the bottom and top cargo lines are systematically flushed with water and stripped dry. This is to remove any pockets and traces of oil in the cargo lines that may leak later and create a toxic or flammable atmosphere when maintenance is being done inside tanks. The adductor and pump is then stopped. All slop tanks and sea chest cargo valves are closed. The ODME is then put back on standby mode. Why is purging with inert gas necessary before gas freeing? The gas freeing of tanks starts as follows. Measure the oxygen content in the tank atmosphere, which should be maximum 8%. Open the tank hatches or suitable openings for purging with inert gas. As the inert gas plant is continuously running and maintaining a positive tank pressure, the tank atmosphere will start venting out through these openings by using displacement or dilution method. Purge the tank with inert gas until the hydrocarbon content is brought down to 2% or less by volume. This purging is necessary to ensure that when air is finally introduced into the tank to bring the oxygen level up to 21%, all hydrocarbon vapors have already been reduced to less than 2%, at which level they are too weak to burn in normal air. This ensures that the tank atmosphere never enters the flammable zone when changing from a fuel-rich state to normal air. How can we know when a tank is safe enough for the crew to enter? Start ventilation either by inert gas fans or by portable water or compressed air-driven fans. At regular intervals, stop the ventilation and measure the hydrocarbon and oxygen concentration. When the oxygen concentration reads 21% and hydrocarbon reads 1% LEL or less, the tank should be left open for some 15 to 30 minutes and then recheck the atmosphere. If the atmosphere readings remain at the same levels, the tank is safe to enter. During the tank cleaning and gas-freeing operation, there should be close radio communication between the duty navigating officer on the bridge and the person in charge on deck. The deck logbook is to be entered with all required operations. The slop tank operational procedure during tank cleaning has been explained in the previous screens. Is water in the slop decanted prior to arrival in the loading port for environmental, safety, or for commercial reasons? After the tank cleaning, the slop tanks are filled with both water and oil, of which water is the greater part. Prior to arrival at the loading port, the slop tanks need to be decanted, meaning that the water is to be removed and the oil stored in one tank. The reason for this is commercial, because water in the tank is of no value, while the oil remaining on board may be sold to slops receivers or added to the next consignment of cargo if load on top is permitted. Decanting of secondary slop tank immediately. Decanting primary slop tank after settling. Click on the thumbnails to learn more. Why should the secondary slop tank be decanted as soon as possible after tank washing is completed? Shortly after the tank cleaning operation, the secondary slop tank will contain mostly water. This water can be discharged overboard via the ODME system, either by gravity or by slowly pumping it overboard until the permitted discharge limit is reached and the overboard valve is closed. MARPO requirements and Oil Record Book Part 2 requirement. The remaining water and oil mixture can now be transferred to the primary slop tank by the small steam-driven stripping pump. As the return from the ODME overboard discharge valve returns to the primary slop tank and also the sample return from the ODME sampling line, the liquid in the primary slop tank becomes fairly agitated. Emptying out the secondary slop tank immediately after tank cleaning, when it is agitated anyway, allows oily water in the primary slop tank to settle without any further interruption or disturbance until it is ready for decanting. Why should the stripping pump be run as slowly as possible while decanting the primary slop tank after settling? The primary slop should be allowed to settle for some 10 to 15 hours, even more if time allows, in order to achieve a distinct oil-water interface. The depth of the oil or water interface is measured using an approved oil-water interface detector. The primary slop tank is then decanted through the ODME by gravity or by pumping. Slow decanting continues until the water layer has been reduced to the minimum or until the permitted discharge limit is reached, whichever occurs first. Once the ODME detects oil content and the overboard valve shuts, pump discharge is diverted back to the primary slop tank, which gets agitated. Is the ship inside or outside special areas? The oil content meter reading then keeps on rising and the decanting operation has to be stopped. Keeping the pumping rate slow and steady allows the separated water and oil layers in the slop tank to remain intact and not mix up, and the overboard discharge valve to remain open for the longest time possible. What steps can be taken to ensure that there is no inadvertent discharge of oil into the water in case of a malfunction of the ODME? To prevent an inadvertent discharge of oil into the water in case of a malfunction of the oil content meter, or ODME, it is important to bear in mind the volume of the oil layer and the approximate ullage at which to stop decanting. That the decanting is done during daylight and a visual lookout is kept over the side so that it may be stopped in case of visible oil traces in the discharge. For details of the use of the oil-water interface detector, see OCIMF Clean Seas Guide for Oil Tankers. The slop tank. Why is it necessary to determine the density of oil in the slop tank in case of several previous grades being mixed in it? Prior to arrival at the loading port, the quantity and quality of the slop oil needs to be measured and communicated to the owner or charterer. If the slop residue consists of several grades of crude oil, it is necessary to determine the density. As different grades of crude oil have different valuations in the international market, the representative density of the entire mixture can help to decide which grade the major part of the residue may be taken to be closest to. This helps to determine a value agreeable to both the ship owner and any buyer of the oil residue in the slops. Which measured values are required to determine the quantity of oil layer in the slop tank? By measuring the volume, temperature, and density, and using the ASTM tables, the quantity of oil in the slop tank at a standard temperature of 60 degrees Fahrenheit or 15 degrees Celsius can be calculated. Click on the thumbnails to look. Which tools are used for measuring the volume and temperature of the oil? The ullage of the oil surface in the tank, and then the ullage of the water surface beneath that, is read carefully using an electronic tape with an ullage and interface detector head. The temperature of the oil can also be read off at the same time, often using the same tape, with a tri-mode function showing ullage of oil, ullage of the water interface, and the temperature. These tapes are always intrinsically safe and used without having to open any tank opening to the atmosphere. Using the vessel's cargo tank calibration tables, which were supplied by the shipyard and approved by the class, the volume of the oil layer is calculated by subtracting water volume from the total liquid volume in the tank. Why should the sample for density be drawn, and the density measured at the same time as the temperature of the oil is read? The procedure to determine the density of the slop is as follows. A sample of the slop oil is poured into a graduated glass. Finding a sheltered place, you put the glass on a plain surface. A checked hydrometer, suitable for the range of density you believe the slop to be, is carefully floated in the oil. After a short while, the hydrometer is floating free in the glass and has found its position of buoyancy, and the density can be read on the built-in scale. In which event can the ship owner lose money because of having slops on board? If there is any doubt about retaining the slops, the master must communicate this question to the owners and cargo owner or charterers and request their advice. Most charter parties provide for the charterer to make the decision regarding the disposition of slops. If the characteristic of the slop oil and the nature of the next cargo permit, the slops may be retained on board and the next cargo loaded on top of them. This is normally done with crude oil cargoes when the same or similar crude will be carried on the next voyage. The charterer may wish to load on top, in which case full freight will be normally paid. Charterers may require the slops to be discharged. The time required to do this normally constitutes lay time used. If the charterer does not wish to load on top, the slops must be segregated and freight will not be paid to the shipowner.